Before we start some new material today, I have some quick warm-up problems for you to do. Can you please take out a blank piece of paper? I'd like you to copy down these three functions. F of x equals 2x plus 8, g of x equals 3x minus 4, and h of x equals 5 minus x. And then I'd like you to try these 4 problems. See what you can do, and you'll send the answers into Edpuzzle. We're going to start by finding f of negative 3. F of negative 3, remember that negative 3 is just what I plug in where the x was. So I'm getting 2 times negative 3 plus 8. 2 times negative 3 is negative 6, and negative 6 plus 8 is 2. Tell me what f of 7 is. Sorry, I didn't mean to say that. I meant to say g of 7. G of 7 is 3 times 7 minus 4. 3 times 7 is 21, so 21 minus 4, I think, should give you 17. Tell me what h of negative 1 is. H of negative 1 is 1 minus negative 1. Change, change. H of negative 1 should be 6. Tell me what f of 2 plus g of 5 minus h of 3 is. Remember, we're going to do the work separately first. F of 2 is 2 times 2 plus 8. That's 4 plus 8, so that's 12. G of 5 is 3 times 5 minus 4. 3 times 5 is 15, so 15 minus 4 is 11. H of 3 is 5 minus 3, and that's 2. So that original problem is 12 plus g of 5, that's plus 11, minus h of 3. H of 3 is 2, so 12 plus 11 minus 2. 23 minus 2, and we'll get 21 out of that. And you're going to do a little bit more practice with this once we finish the new material today. Today's practice will be a little bit of the old stuff and a little bit of the new stuff. Let's get the notes out. So please take out your notes. And we're on page 33 in the notes. Page 33. I'm going to make the video pause for a moment so you can get ready. First thing we're going to do is I just need to remind you of our definition of a function from yesterday, although I'm going to add a tiny bit in there. A function is a mathematical rule. A function is a mathematical rule where you input one number, which is going to be our x value. We saw that yesterday with the f of x. I told you what x was. And you output, one number. And I'm going to call the number you output y. Take a moment, copy that down. A mathematical rule where you input one number, the x, and you output one number, the y. I have 2 graphs shown. What we're going to spend today looking at is how to deal with functions from graphs. This first one is a function, but the second one is not, and I need to tell you what makes them different. I'm going to label the first one, though, as a function, and I'm going to label the second one as not a function. Take a moment, label them, and I'll tell you why one is a function and the other is not. In the first one, if you pick an x value, like negative 2, I can find one y value on the graph, -2. If I have an x value of -1, my y value on the graph is -1. If my x value is 1, my 1y value on the graph is 1, and so on. Every x value has only one y value. But that's not true in number 2. An x value of -2 here has two different y values. When x is -2, I see a y value at 1 and another y value at about 4. That's not okay, which is why this is not a function. I realize that sounds a little bit tricky. There's an easy way to figure out if a graph is a function or is not a function. And this easy way is called the vertical line test. What it says we should do is we should take a vertical line and we should slide it across our graph. Take a vertical line and slide it across our graph. If it ever hits the graph in two or more places at the same time, it is not a function. My vertical line test says slide a vertical line across the graph. If it ever hits the graph in two or more places at the same time, it is not a function. I'll make the video pause so you can get that all copied down. Slide a vertical line across the graph. If it ever hits the graph in two or more places at the same time, it is not a function. When I slide my vertical line across that first graph, it never hits in two places at the same time. It's a function. But over here, when I slide that, I'm okay for a little while. But over here, I start hitting in two places at the same time. Not okay. Not a function. This one's a function. This one's not. I'm going to practice a little bit with some of this function, not a function stuff. Let's take a look at some of these graphs, which you don't have. We're just going to kind of do them from the video. This first one, if I slide a vertical line across my graph, I think it's hitting 2 points here, and here, and there, and there, and all over the place. That makes it not a function. If I slide a vertical line across number 2, I don't think I ever hit 2 points at the same time. That's going to make it a function. In number 3, if I slide a vertical line across that graph, I don't think that vertical line's ever going to hit 2 or more points at a time, so that's also a function. See if you can do 4. Number 4, slide a vertical line across that graph. Never hits 2 points at the same time. Yes, it's a function. Do 5. Slide a vertical line across the graph. Oh, problems all over the place over here. I'm hitting 2 points, 2 points, 2 points, 2 points. Not a function. Try number 6. Slide that vertical line across there. Yep, that's a function. Try 7. I think it fails that vertical line test. I think a vertical line's hitting 2 points, 2 points, 2 points, 2 points. Not a function. Try number 8. Vertical line will never hit 2 points at the same time. 8 is a function. Try number 9. I think a vertical line's going to be hitting 2 points over there and there, and not a function. We are going to spend the rest of today focusing on graphs that are functions, and we're going to see how to evaluate functions by looking at a graph. Continuing in your notes. we're now going to turn to page 34. So take a moment, get your notes out, turn to page 34. Evaluating functions from their graphs. I am giving you this time not a formula for f of x, but a graph of f of x. Kind of a strange looking graph of f of x, but that's okay. My first question for you is that graph a function? Sure it is. I think that graph's going to pass the vertical line test. Vertical line will never hit in two places at the same time. So yes, it is a function. And I'm going to call it f of x. The first thing I want you to do is we're going to try to figure out f of 2. Here's how these problems work. Just like yesterday, this number is going to be our input, and I want to get an output. To figure this out, though, from the graph, our input is an x value, our output is a y value. So I'm going to tell you an x, all you're going to do is tell me the y. Let me write that down. I tell you the x value. You tell me the y value. I tell you the x value. You tell me the y value. Copy that down. To do the problem f of 2, I'm telling you if our x value is 2, what is our y value? So I'm going to go find my graph when x equals 2. I think when x equals 2, my graph is right over here. What's my y value? My y value is negative 2. What this problem asked is when x is 2, what is the y value on the graph? And we saw that our y value when x is 2 is negative 2. If I want you to find f of 4, that means 4 is our x value. I want to follow my graph until I get to an x value of 4. Oh, I'm here. I've got my x value of 4. You tell me the y value. When x is 4, what's the y value? I think that y value, when x is 4, looks like 0. The nice thing about these is we don't really need any work. We're just getting all of our information from the graph. I'm telling you an x, you tell me a y. F of negative 3. Let's see, I'm going to go over to negative 3. You tell me the y value on the graph when x equals negative 3. I think when x equals negative 3, that y value on the graph looks like 2. F of negative 3 is 2. See if you can find f of 8. F of 8 means 8 is our x value, our y value, looking like negative 4. F of 8 is negative 4. 2 more problems. Oops. I can move this up a little bit. F of 1 plus f of 7. And we'll do these just like we did them yesterday. I'm going to figure this one out. When x is 1, what's the y? Then I'll figure this one out. You know what? Rather than 7, let's make it negative 7. Let's change that to negative 7. Sorry about that. You know what? Let me cross it out and start it again. F of 1 plus f of negative 7. And then I'll just add the answers together. So what's f of 1? F of 1 means my x value is 1. The y value I see on the graph, it's over here. It's negative 3. What's f of negative 7? X value is negative 7. The y value on my graph is negative 2. So negative 3 plus negative 2, we're going to get negative 5. Last one. See if you can do f of 6 divided by f of negative 6. We're going to do f of 6 divided by f of negative 6. Well, get me started. What's f of 6? F of 6 looks like 2. F of negative 6 looks like negative 1. So what is f of 6 divided by f of negative 6? 2 divided by negative 1? Negative 2. And the whole point is now we know two different ways to what we say evaluate functions. If I give you a graph and ask you what's f of 2, I tell you the x, you look at the graph, you tell me the y. The other way we can do this, though, is what we did yesterday. Let's say I give you g of x equals 2x plus 5. If I want you to find g of 3, well, we don't have a graph, but that's okay. I can do what we did yesterday. I'm going to plug the 3 in where the x is, and I'm going to get 2 times 3 plus 5. I'm going to get 6 plus 5. I'm going to get 11. If I give you a formula, we plug it in. If I give you a graph, you tell me the y value. This is what you're going to practice in one of those self-checking activities in just a moment.